Okay, so let's start with a big question. A real head scratcher. What do you, a super distant star, and just a single drop of water all have in common? It sounds like the start of a weird joke, right? But the answer, well, it pretty much unlocks the secret to, well, everything. Let's dive in.
So just take a second and look around. I mean, really look. You've got the chair you're sitting on, the air that you're breathing right now, even the stars way up in the sky. They all seem completely different, don't they? Worlds apart. But here's the thing, they all share one single fundamental secret.
And that secret? It's that all of it, every last bit, is made of the exact same basic stuff. It's kind of wild. Scientists have a name for it, of course. They call it matter. So, the food you eat, the phone in your hand, the clouds floating by, it's all just different arrangements of this one single universal ingredient. That's it. Okay, so what exactly is matter? What's the official definition? It's actually really, really simple. If something takes up space, has volume, and it has mass, then yep, congratulations, that's matter. Simple as that. For the longest time, some of the smartest people in history argued about this. What was matter really like deep down? Was it one solid continuous block, kind of like a big piece of wood with no gaps? Or was it made of zillions of tiny, separate little bits, more like a pile of sand? Well, guess what? We can settle this ancient debate right here, right now, with a super simple experiment. Okay, picture this. You take a glass of water and you mark the water level with a pen. Super precise. Then you dump in a spoonful of salt and stir it all up until it completely dissolves. Now, common sense says the water level should go up, right? I mean, you just added stuff to it. But it doesn't. Not even a little bit. So what in the world is going on? Where did all that salt just go? And here's the big reveal. Matter isn't a solid block at all. It's made of tiny particles. The salt didn't just vanish into thin air. Nope. Its tiny little particles just slipped right into the empty spaces between the water particles. It's like finding parking spots in a crowded lot. So yeah, that old grains of sand idea, it totally wins.
All right, so we figured it out. Everything's made of particles. Case closed, right? Well, not quite, because that just opens up a whole new can of worms. Like, just how small are these particles? Are we talking small, or are we talking ridiculously, mind-blowingly small? I love how the source material puts it. With 4 exclamation points, it says they're small beyond our imagination. And that's not an exaggeration. Get this, there's an experiment where just a couple of tiny crystals of a chemical can turn 1,000 liters of water bright purple. 1,000 liters! That means each one of those little crystals must be made of millions, maybe billions of particles that spread out through all that water. They are, unimaginably small.
So, the big question is, how do all these trillions and trillions of tiny particles work together to create, well, everything? The chair, the water, the air? It all comes down to 3 surprisingly simple rules. Think of it like a dance. And if you learn these 3 steps, you basically understand the blueprint for the entire universe. Okay, rule number 1. We've actually already seen this one in action. Particles have space between them. It's the whole reason your sugar dissolves in your coffee or your salt disappeared in the water. And it's also, why fish can breathe underwater. Tiny particles of oxygen can actually squeeze into the gaps between water particles. Pretty cool, huh? All right, on to rule number 2. And this one's a biggie. These particles are never still. Ever. They are constantly moving, jiggling, and vibrating. They've got what scientists call kinetic energy, which is just a fancy term for the energy of motion. So just imagine them, always bouncing and zooming around 24/7. And this idea of constant motion, it explains so much. Like, think about this. Why can you smell hot, sizzling food from all the way across the room? But for cold food, you pretty much have to stick your nose right in it to smell anything. The answer is all about that kinetic energy. It's the heat. When you cook something, you're basically giving its particles a massive energy boost. All that extra kinetic energy makes them move way, way faster. They break free and literally fly through the air all the way to your nose. The particles in cold food, they're much more sluggish. They have way less energy, so they don't travel nearly as far. And that brings us to rule number 3, the final piece of the puzzle. Particles attract each other. There's a kind of force that holds them together, a bit like how these dancers are holding on to each other. Now, the strength of that attraction, that grip, can be really strong or pretty weak, and it's different for every substance. And that is super important for what's coming next.
Okay, so let's recap. We've got our 3 rules for the great particle dance. They have space between them, they're always moving, and they attract each other. Space, movement, attraction. It's just those 3 ideas we can explain the 3 main states of matter you see all the time: solids, liquids, and gases.
This table really lays it all out. In a solid, right, that attraction is super strong. The particles are locked in place, just vibrating. That's why a rock has a definite shape. In a liquid, the attraction is a bit weaker. The particles can kind of slide past each other, which is why water flows. And in a gas, the attraction is almost zero. The particles are just flying around like crazy, full of energy, filling up any space they can. So if solids, liquids, and gases are just different styles of this particle dance, can we, change the song, force them to dance differently? Absolutely. And all we really need to do is crank up the energy. And the simplest way to do that? You guessed it, just add heat. When you add heat, you're basically injecting pure kinetic energy into those particles. They start vibrating faster and faster, they start pushing against each other, fighting against that force of attraction, until finally they get enough energy to break free and change their whole dance routine. They change their state. But check this out, there's a really weird thing that happens. When ice is melting, the temperature gets stuck at 0 degrees Celsius. It doesn't get any warmer, even though you keep adding heat. So why is that? Well, all that heat energy is being used for one specific job: breaking the bonds that hold the ice particles together. It's like the energy is hidden while it's doing this work. Scientists have a cool name for it: latent heat. And you don't always have to boil something to get it to change state. Think about a puddle drying up on a sunny day. It's not boiling, right? What's happening is that some of the particles right at the surface just happen to have enough energy to break free and escape into the air as a vapor. We see it all the time. We call it evaporation. Which brings us to something we've all experienced. You can totally explain this with science now. On a hot day, why do we sweat? How does that actually cool us down? It's pure evaporation. That sweat on your skin needs energy to turn into a vapor. It needs that latent heat we were just talking about. And where does it get that energy from? It pulls it directly from your skin. So as the sweat evaporates, it's literally stealing heat from your body and carrying it away, which is what makes you feel cooler. Pretty clever, huh? So, there you have it. From a simple grain of salt disappearing in water to the way your own body cools itself down, it all comes back to the same thing: this invisible, non-stop dance of countless tiny particles. So the next time you look around at our solid, stable-seeming world, just remember, what you're really seeing is an incredible illusion hiding this amazingly energetic and dynamic universe that's happening just beneath the surface. So, if everything is just particles in motion, what does that make our reality? Now that's something to chew on.